Okay, so we are picking up in lesson 1.7 with example 3. And example 3, we get to talk about percentages. We've got salary increase, the cost of an item. So how to put in an equation, increases, decreases, those type of things. So our problem reads, Mark received a 8.5% salary increase. His salary after the raise was $36,090. What was his salary before the raise? Okay. We want to try and set up an equation to think about this. What is it they're asking us to find?
His salary before the raise.
His salary before the raise. So what do we need a variable for? His salary before the raise, yes? Okay, so I'm going to say that that is X. Okay. Thoughts here? We know it's an 8.5% salary increase. We know his final salary was $36,090. We want to know his salary before the raise. If I want to write an equation, or in other words, a function to model this, do we know a total amount that we can make our equation equal to?
The 36,090.
Yeah, the one that's kind of blurred, that it's hard to read what it is. But we know a total amount of $36,090. So I'm going to make my equation equal to that $36,090. Now, how do you get that $36,090? You have what?
Add the percentage, like salary increase.
Okay, we're going to have the however much the salary increases, right? And what are we adding that to?
The initial salary.
The initial salary, right? So what is the initial salary?
X.
X. So I'm going to start off saying X plus, so that's the initial salary, plus, how do we find his salary increase? Okay, so we're going to multiply by 0.085 to find his salary increase. What are we multiplying that 0.085 by? Not the 36,000 number. The X. In other words, if we're doing the 8.5% increase, that 8.5% increase is on the initial salary, which that's the frustrating part. We don't know that, right? Which is why I'm trying to set up the equation. So we're going to do the 0.085 times X is what we're saying here. Now, do I need to talk about the fact how we make 8.5% into a decimal? You move the decimal 2 places left, and it is 0.085. We know that, right? We're pre-cal. Just a friendly little reminder if that had slipped your mind. But the idea here is what we have is we have X, which is the initial salary, plus we're adding an increase. The increase is 8.5% of the initial salary. So 8.5% times X. When we add those together, it's going to equal the salary after the raise. Okay, what can I do with this equation here? What's X plus 0.058X? Yeah, 1.058X, because what's the invisible number in front of X here? There's an invisible 1 there, isn't it? So 1X plus 0.085X is going to be 1.085X equals $36,090. How do I solve?
Both sides by 1.085.
Okay, divide both sides by 1.085. What is $36,090 divided by 1.085?
$33,260.67.
Is that what you guys got? Because that's not what I've written down. Oh. Okay. I see why it's not what I have written down. Okay. I didn't use 36,090. I know it's so easy to tell. I actually used 36,890. That's why your number and my number doesn't match, because my number comes up to be a nice, neat whole number. So how confusing is if I backtrack and say, okay, that was really supposed to be 36,890. There's the number I was looking to hear. Sorry, that's not the least bit confusing on your teacher's behalf at all, is it? At least I'm owning up to my own mistake here. Okay, so if we use 36,890, which was the original intention, and divide that by 1.085, it becomes a nice, neat 34,000. That's 34,000 what? Dollars. Can you check your answer? Can you think through it logically? Does 34,000 make sense? Yeah, you can. You can find the 8.5% increase. You can add to it and figure it out. Okay. Now take what we just talked about there and look at the other part of this example. This is what is the cost of an item after a 45% decrease. So my answer is going to be in terms of X here, or in terms of a variable. In other words, I don't have a number here because we don't have a number of an original price or anything. But in order to do a 45% decrease, think about it kind of like we did the left side here. How would we do a 45% decrease similar to how I did the left side of my previous equation? What's the original cost of the item? X. How are we going to find a 45% decrease?
Times it by 0.45.
Okay, so in order to find the 45% decrease, we times X by 0.45, right? And then how do I actually find the final price then? We have to subtract it. Does that make sense? So if X right here represents the original cost, and we're trying to find a decrease, so then we're going to subtract off 45% of X. So just trying to get you to think in terms here. What is X minus 4,500 X? Yeah, 0.55x. Because, of course, out front, this is a 1x, right? The original cost is just 1x. You're trying to decrease, so take 45% x off. We're at 0.55x. Now, calculator shortcut. If you're trying to find 45% of something, yeah, one option is multiply it by 45 hundredths and then subtract it from the original price. What's the shortcut? If it's a 45% decrease, it's how much of the original amount? It's going to be, what's that 0.55 mean? Yeah, it's 55% of the original price. Okay? You know, my shortcut in the store, you know, if I'm out shopping and something is 30% off. Yeah, I might estimate, but I also might grab the phone on my calculator, and I don't take the time to find 30% of something and then subtract. I just go, if it's 30% off, how much am I going to pay for it? I'm going to pay 70% of the price, so I just do the price times 70%. Okay, so it's a good, it makes the math a little easier. Just like if I'm trying to find the tax on something. To me, it's a waste of time. I don't waste my time finding 7% of something and then adding that to the original price. what is your price after you add tax on it? It's 107% of something. So I multiply 1.07 times the amount of the item, and that tells me what the price is with tax. So, I don't know. I don't know if that's helpful or not. Maybe you guys already know that stuff and have figured that out, but that's the math nerd in me. So, okay, questions on this one? Okay, let's go to the next page. Okay. Example 4. A square is inscribed in a circle. Write the area of the square as a function of the radius of the circle r. You got that all? First of all, let's figure out what this picture looks like. A square is inscribed in a circle. Do you guys know what that means? There's my circle. If the square is inscribed in it, the square is inside of it, and what's the square do? It has to touch. Oof, that did not work out. Well, okay. I don't know how to even fix that right now. Okay, pretend. You guys have great imaginations, right? You're imagining that is a nice equal 4 sides, equal angle square inscribed in a circle. The idea is each vertex of the square touches the circle, right? That's the idea. Now, we want to know the area of the square as a function of the radius of the circle r. So we want area of the square. We want it in terms of r. Now, let's talk about what is area of a square. Length times width, which I agree with, but what do we know about the length times width in a square? Length and width in a square are the same, right? So when you are in various math classes, you will usually see the area of a square is written as s squared, where s represents the length of the side. So in other words, instead of saying length times width, which when we think length and width, we usually think 2 different dimensions, it's like saying length times length or width times width. But we usually just use s for the side of a square. So side of a square times itself is s times s. So we want to take this area formula, but instead of writing it with s, we want to write it with r. So we have to find the connection here. Okay. Where's radius? Radius goes from the center of the circle out to the edge of the circle, right? Now, I can draw a radius wherever I want, going from the center of the circle out to the edge of the circle. But there's a nice little place that will kind of match up and be helpful here if we do it right, in that right there. Because now I'm meeting up with the corner of the square. So right there, that is an R. Could we draw other R's? We could draw 4 more. I'm not going to draw 4 more, but I'm going to draw a second one here. Okay. I need you guys to figure out the connection between R and S. Because here's the deal. We need to take this equation, A equals S squared, and pull the S out and put R in. What are you thinking?
Can we use the Pythagorean theorem?
Pythagorean theorem it is. Do you guys see the right triangle here? This is a right triangle. I want you guys to try and see it first. But if you take the center of a square and you're breaking it into 4 triangles, that is a right triangle. And so Pythagorean theorem, remember Pythagorean theorem? We haven't used Pythagorean theorem in this class yet this year, have we? Yet. We'll get lots of use of Pythagorean theorem. A squared plus B squared equals C squared, where A and B are your legs meeting at a right angle, and C is the hypotenuse. What are my A and B here? A and B are the legs, so R and R. R squared plus R squared equals S squared. What's R squared plus R squared? 2R squared. And what's the deal? We have to be able to substitute into this equation for S, right? So general rule of thumb is that we're going to take this equation and we're going to solve it for S. So how do you solve this equation for S? Square root, right? If it's S squared, we're going to take the square root. If you square root one side, you square root the other side. Now, with that in mind, the square root of S squared is S. What's the square root of 2R squared? Actually, I'm going to reverse that. Dang it. Aha, got it. Square root of S squared is S. What is the square root of 2R squared?
Just square root of R.
Not exactly. Wait, depends on how you meant that. So can we take the square root of 2? No. Can we take the square root of R squared?
Yes.
Yeah, what's the square root of R squared?
R.
R. And so what you could rewrite this is R square root of 2. Okay. Now, what am I doing with this S equals R square root of 2? I'm going to put it where? Back in here, yes? Now, there's a couple of different ways you guys can do this. I don't know if anyone caught it here. On this particular problem, we actually could have stopped here because what did we have? We have S squared was equal to 2R squared. What do we have in the formula here? S squared. So honestly, we could have possibly stopped there. However, wow, I obviously rubbed against that. We also could use the square root of 2R squared, or we can use R square root of 2. Okay, you can use any of those. So if I put this as R square root of 2 back in here, and we square it, because we're replacing S, well, R squared becomes R squared. When you square root of 2, it becomes 2. And so we end up with 2R squared. Thank you, Landon. Don't forget to turn in your quiz review worksheet at some point.
If I turn it in next grade, I have it. Or I can turn it in now.
Either or.
Okay.
Yep. Okay. Are we good with this? A equals 2R squared, one way or another. Okay. Whether we square root it here or have to square it here using either of these, or just filling in S squared equals 2R squared. Okay. Example 5. Last one. A number added to 4 times that number is 450. What are the two numbers? A number added to 4 times that number is 450. What are the two numbers? Now, I'm going to tell you, I want us to think equations, functions, not just taking your calculator and playing around and finding out what the numbers are. I know it's much easier to do that sometimes, isn't it? But how can we do this with an equation? So, read this. A number. What do you think I'm going to say we use? X in whatever you want. Added to means what? Plus 4 times that number. What was that number? X. So what's 4 times that number? 4x is? What's is in the math world? Equals 450. Did we just write an equation we can use to solve this? Yeah, what's x plus 4x? 5x equals 450. If 5x equals 450, then what? Divide by 5, and x is 90. Am I done? What did my question ask? What are the two numbers? Yeah. One number was x, which is 90. The other number is 4x. And 4x was going to be, it would be 4 times 90, which is 360. So my numbers are 90 and 360. Okay, look for ways to write those equations. Okay, your homework, if you haven't already written it down, page 148, numbers 1 through 16, 18, 19, and 21 through 23. Did I do that right? Did that by memory, which is always scary. Okay, you have work time. This isn't done. I would encourage you to work on this. What? Out of the 6 of you sitting in here, I'm only losing 2 of you tomorrow, aren't I? So, tomorrow in class, we can check this for those that are in here. If you're not in here tomorrow, you can show it to me on Monday, or stop by and show it to me tomorrow. Just make sure you show it to me on Monday, because it will go on this 9 weeks it ends tomorrow. Okay? So no big deal if you wait till Monday. I can handle that. Just make sure you show it to me on Monday. And then I'm going to hand out review worksheets, just that way if you're not in here tomorrow, you know, I haven't decided when, but the test will be sometime next week is what I'm looking at. Okay?